Hello. Bear with me 1 second, as even though I tested everything before the stream, it seems we're still not showing properly. So this is turned out to be a bit more complicated than the usual game streaming and things that I've done in the past. But here we go. So technical difficulty straight off the bat, which is always the way, I guess. But yeah, welcome to our to my new series. I'm calling this crafting a crawler, and the end game of this is that, well, the end goal of this is to try and build out a brand new dungeon crawling RPG from completely from scratch. No skills in the area. It's a ambitious project, probably a bit too ambitious, but it's going to be interesting to. Sorry, it's going to be interesting to see where we land on it. So, as a bit of a background, this whole series is stemming from the fact that a significant amount of time ago, when I first learned to program, towards the end of the last millennium, which makes it sound about as long ago as it feels, I started to learn to program just because I wanted to build games, and that never actually came to fruition. I did become a programmer. I've built loads of very complex and very boring systems for facilitating capitalism over the years, but I never got to build the game. So yeah, this is going to be my foray into game development, and I thought I would record it and share it and try and take everyone else on the journey. So just to give some context, we are going to be we're going to be using the Love 2D framework. So this is a framework for building games. It uses the Lua programming language, something I'm also not overly familiar with, but we'll learn that as we go. It's quite low level, so I thought there were various things I could have done. I could have picked up Godot or something for this instead. That would have probably been the smart thing to do, but smart isn't funny. So, and funny is always gonna trump everything else in the end, right? So I've learned from my game related streams that audience tends to enjoy watching me suffer more, and this seems the path of reasonable suffering. The other thought I had was to build everything completely from scratch and build it in something like C, but that would just be a lot of very boring streams before we actually got to see anything happening on the screen. So yeah, I thought this Love seems to be a good compromise. It has some fairly decent documentation. It provides just enough of the primitive functions so that we can sort of just load an image and draw an image to the screen, but we're not going to have to actually get into the nitty-gritties of just loading an image from the file system. But for instance, unlike something like Godot or Unity, it's not going to just give us a map out of the box. So things like that we will have to do ourselves, and we can have a deep dive into how that stuff works. But yeah, so I will say excuse me a bit, because this is the first time I've actually had a face cam up on YouTube. And I can see it on my screen, and I'm incredibly self-conscious of it. Which you'd think in today's remote world would be less of a concern, but no, it's still there. But yeah, so let's get cracking. I have a basic project structure here. This is available on GitHub in the Artisan of Code repository under the Untitled Dungeon Crawler repository. There is, I believe, a link to that in the video description. And a wild Captain Crumbs has appeared. Hi, and welcome in. Yeah, so is the bot awake? No, I did. Oh, yes, it is awake. It's just taking its sweet time. Cool. But yeah, so this is our code so far. It's there is absolutely nothing here. It's just got a little README. It's saying effectively what the goal of this project is. The fact that we're going to be building this in the open so that people can look at it, follow along. A little bit on licensing, because I want to make sure that we build something that is cool and people can sort of grab the code and have a poke and see how it works and everything else. But we don't want to be feeding into the toxic sort of trait of people just grabbing code off the internet and compiling it, shoving it into app stores, and probably putting some toxic monetization in it. That's something we wanted to avoid. So, but yeah, so I've got a link to some of the tools you might want here, the framework, and to the editor that I'll be using. A little bit about the project structure. We have a Discord and a discussion forum. If you want to talk or chat or find other people interested in this sort of thing, some boring licensing crap that basically comes back to what I mentioned earlier, and yeah, so we have that, and we also have our window. So I said the basic thing. We've got our README and not much else. So part of yeah, there is a face to the voice. Hi, Splash, and welcome. Hopefully the face is not going to scare too many people off. I did have to make sure that the not safe for kids box was ticked. I don't want to be responsible for any children growing up with more trauma than they have to. But yeah, so so where to start? So I have done a bit of a reconnoiter on how some of this stuff works. So so if we head to the browser briefly. So there is a wiki for Love2D. This has all of the documentation on it, and also has a bunch of quick starts and tutorials. But having read that, a game basically starts with two files, and I've worked out that my preferred layout of the game is not going to work particularly well. Braver than you have a face for radio. Yeah, I would say I have both a face and voice. Sorry, a face for radio and a voice for TV, but or maybe even I have a voice for the written medium, but that's it, right? A voice for newspapers. But yeah, a Love2D game comprises at its core of two files. We have both of these are Lua files. Lua is a programming language, which we will find pretty quick. It is a pretty cool little language. The version that is in Love2D is the version 5.1. Oh, no, we don't need to download that. Yeah, so we'll probably be referring to the Lua documentation for a bunch of stuff. But yeah, as I said, there are two main files. There is the main.conf. This is, sorry, main.lua. This is where our game logic is going to be. Trying to remember how comments in Lua work. Is it the hash? No, it's the sorry, it's the double slash. I'm hoping this is big enough for everyone to see in the background. Here, and that the text isn't too small. Maybe, yeah, let's go up a little bit more. We'll go up a bit more, and if I quickly have a look here, let's try and shift me over a bit out of the way. There we go. I'm more central in the camera than I thought it was going to be. So sorry that. But yeah, so we have our sorry, it's double hyphen for a comment. Okay, we are learning here. But yeah, so if I quickly jump back to our browser, what we have here is on there we have a section on config files, and this is the base config file, so we're just going to grab that and we're going to drop it in here. There's a lot of stuff here. I think the main thing we want to have here is we also have a extension to help us test things. So where is that? That is the Lua local Lua debugger, and if memory serves, this has for us. Here we go. So this has a config file for us here to run our game. They actually have added in some extra stuff added in some specific hints to help us. And yeah, let's start with that. And then we will drop in the example from the documentation, and we are going to have dot in computing in when it comes to locations means the current folder. So we're going to, and our game is in our current folder, so we're going to launch that. And this will help us debug the game. So if we, well, I say if, I mean, it should probably be when we hit problems, we will be able to debug things. So, and figure out what's going on. And then it gives us a little snippet to put at the top of our main.lua file. Debugger, I can type. There is a long-standing enigma, I think, when it comes to coding, in that for some reason the more people that are watching, the less able you are to the lower your accuracy is when it comes to hitting hitting the keys you want. So yeah, so with that we should actually have a working thing. So if we run the game and then if I set this up properly, sorry, I realized that I had the browser overlay open, so you guys missed all of that. So what we did there is we went into here and we set up the launch config. This is based on the documentation from the Lua debugger, which is an extension for VS Code, and comes with a very convenient thing for us to copy pasta out of here, and it is specifically to run our Love2D games. And it gives us a little snippet to paste into the top of our main.conf. Sorry, our main.lua. And that will give us a working debugger, which is a tool that will allow us to figure out what went wrong when something goes wrong. Haven't done much programming except for a few lines of HTML back in the day. Yeah, it's going to be interesting. This is my first real attempt at any serious Lua code as well. So I will apologise in advance that if anyone who does know, watching this does know Lua, then they're probably going to be shocked and horrified at what I'm doing for half the time. But we'll get there eventually. And like any project, the stuff we do at the start here is probably going to be redone and destroyed, and well, we'll probably have redone this 3 times over by the time we get to the end, to the point of a fully functional game. Yeah, so with this we should be able to run the game. If we hit that there, that has opened a window for me. If I show this, okay, here we go. Yeah, so at the moment we have a game. It's opening a window. We've got nothing on it though, which is I guess it's a good start, right? We've at least got the window there. That is more than we just had. So if we've got that, we can now close that. And let's look at actually getting something to happen. So if we go back to the wiki, they give us a little quick demo here, and they give us a draw function, and we are missing extensions for the Love2D for the Love2D library, because it's claiming that love does not exist. a harsh view from the machines, but yeah. So Unity is a lot higher level than what we're doing. So so we need to we need to add some special incantations to the. I think there should be a. No, it's in. None of these are actually helping too much. Let's just try and figure this out ourselves in the editor. So what we need is to settings. We want to open the workspace settings, and then let's have a look in the Lua. 。 let's have a little bit of a nose. Hang on, they were. I think there is actually an extension. So I was looking at this, and there is Love2D support extension, but this doesn't actually give us much in the grand scheme of it. But I'm now remembering, if I remember right, there was it this one that had the little snippet that told us where the no. No, it wasn't this one either. Do bear with me a sec. I will find this. So what we're looking for is a way to configure our environment so it actually knows about the framework that we're using. You can all watch me be terrible at Google instead. Love2D. So it was VS Code. I think it was Lua. Something on here about third party. Here we go, Lua something. So we just need to find the right setting for it. Here we go. So VS Code. And we definitely want that in the search results. Here we go. So here's a bit. Well, we'll add in the runtime version because we know it's using LuaJIT, which is a faster version of Lua, and no, that's not enough, which is specifically the search term we asked for. I do hate Google nowadays. Let's go for a verbatim. No. Oh, well, rather than spend ages on this, we will figure this out. I think we can figure this out on I can figure this out offline, and we can get it working. It's not going to be too important for now. But let's flip back to our editor. Let's just flip back to edit and let's have a look at what we've got. So with this, we've updated this. We've added a draw function, and the draw function gets called every frame. So a game is effectively just a series of frames shown to the screen. This is what we see, what we interact with, and where a lot of our logic happens is in the generation of those frames. So what we're saying here is that, and what this framework will do is every frame it will call this function, and this function is then responsible for drawing everything onto the screen. And so if we if we run our game, we now have a new window and we've got Hello World in the middle. So, okay, it's not quite a game yet, but it's getting there. So we've got that. So next up is if we go back to the wiki and have a look in the graphics section. This is where we can find our drawing functions. So if we take the circle one, for instance. Oh, sorry. If we look in the if we look under love.graphics, we'll get these are the functions we can use for drawing. Some of these, most of the interesting stuff will happen when we start drawing pictures and stuff. But for now, we can add a circle, and we can take that. We can go back to our code, and if we drop in the circle, this needs a mode. The mode is either fill or line, so we are going to want to fill our circle. We'll give it an X and Y. So if we say we want to draw it at 400 and 300, so what this means is this will be X and Y positions. So this will be 400 pixels across from, this will be 400 pixels across from the side of our screen. So we can see that in our previous example. If we run this now, we get an error because I did not specify a radius. Let's go for a radius of 32. So let's give this a run now, and if we look now, we have a circle drawn, 32 pixels centered on the screen, and this will be then if we change these settings. So this value here is how far across it is from the left hand side of our screen, and this is how far down it is from the top of our screen. So if we change this to say 200 and 100, then it should move up towards the top. Oh no, the top corner of the screen. Yeah, the flip camera is a bit weird. We'll not try that one again. But yeah, so we've moved up now. We have moved up now to the top corner. So the other important function we get is there is a love dot update. So this one here is for updating the state of the game, and that will get called periodically with a dt, which will be the number of seconds as a fraction that have passed since the last time it was called, and then we have our draw one, and this will be in here. We will draw things to the screen. We can probably get rid of that now. And what we can do, we also have a function love.load. This is our startup. Tasks, and we should also have a function love.is event. Let me quickly, let's have a quick look at the wiki again. Yeah, so we have the load, we have the update, and we have the drawing. And then there should be there is also a event one. So what should be an event one? Okay, so no, I think we have to process the events separately. So, okay, so this will give us our events. And we can use that to figure out any input that's being done. So here we go, event. Yeah, so this is the event that we will get back, and the type of events that we can get. So what we're going to want is some keyboard and mouse events. So where are those? We want the key press. Key pressed and key released are the two that we will care about. Oh, so if we go back to our little test window now, we can now have we can create two variables. And let's set these to 400, and we'll have local y equals 300. And what we'll draw is we'll draw our oh, sorry, got those the wrong way around, x and y. So if we draw those, we will get we should end up back where we were just now, but now we're using variable. Oh, we have a error. So oh, sorry. So this was not set up properly. So yeah, so sorry. We had the remnants of that there. We don't need that. That's not how it works. So we can run this again. Oh, and we have a circle in the middle. But yeah, this is going to be where this differs immensely from something like, say, Unity or Godot, where in that we can just go in and it just does all this sort of stuff behind the scenes for you. So you don't really have to know how it works. And I like to know how things tick. I like to see what's happening under the hood. The way that I learn is that I like to take something apart, break it, and put it back together. That's how I sort of wrap my head around things. So one of the things we want to do is do we have actually? So if we go back to the wiki. Here we go, getting started. We should be able to pick up. No, this was not the page we wanted. If we go to the events, no, love. We want to find the callbacks functions that are available. So. Right, there is no key press, so yes there is, sorry. I am just blind. I was not paying good attention. There is a key press and key released function. So we want to trigger this when we want to trigger. Sorry. Yeah, there was some keyboard events. I just looked at these top few and missed that there was a whole bunch of extras. So We have the keyboard events here. We have a key press and a key release. So we want to add a love.keyPressed function in here. And let's set let's set these in here, and if we take off the local, they will just generally apply for now. We will fix these up later because we're going to want to arrange things a bit better. But if we have a key pressed, and we also want a key released, a key released event. So let's take these two. So with these, we're going to know when a key is being pressed and when a key is being released. And then actually, so I just did notice in the wiki that there is also a way to check that if a key is down, which might actually work a bit better for our use case here. So what we want in our update function is to know if a key is down, and if the key is down, let's go with W. W is up, so we want to go y equals y minus 1, and then we have to times it by dt. So this will mean all the time that we have our key held down, it's going to change by, it's going to move up by 1 every second. That's a bit too slow. Let's go for, we want to go up by 10 every second, right? We'll be able to see that. Right? Then we're going to want a S, and if it's an S, then we want to go and increase it by 1 each time. And if it is an A, then we're going to want to do the same for X, and we're going to want to decrease by a rate of 10. And if it is a W, then we will want to increase by a rate of 10. So now, if we give this a run, we have, oh, sorry. Yeah, so what I did there is we're setting out X and Y when the game loads, and we're setting it to 400 and 300. And then we're checking if a key is down, we're looking at W, S, A, and D. And if W is down, we decrease by 10 times this factor, which is the difference in time, the delta time between the last time it was called, and that will be a fractional number. So if this is getting called 10 times a second, each time this will move by 1 pixel, because this will be 0.1. That makes the maths a lot easier. It's probably, hopefully it'll be called up to, well, 60 plus times a second. So and then the same, we have the same for S. We go, we increase the value by 1, which will push it down the screen. The A, we will push it to the side. We'll push it to the left, and the D will push it to the right. So now if we run things, we open the game window and we hit the WASD keys. Oh, that's moving. It's a bit slow. It's very slow, but it's sort of moving. All right. So what we've learned is 10 is not a good number for the speed of things. So we should actually give that a so if we give this a speed, let's set this to a variable so we can set it in all the places at once. So we, rather than have it set to 10, we're gonna now let's try it with 50. And this is a lot of what programming is just to randomly sort of look at things and see if, try something, you run it, you see if it works, see if it does what you intend, and then you go back and try again. So that's a bit better. Turns out 50 is also really slow though. So if we go up to 100, then that's a bit more. That's a bit more what we're after, right? So we can see now that we can now move the circle around the screen, which is nice. We've also got, but we do have one thing here I've noticed. This is so this is something you see in a lot of games. Minecraft, for instance, has this, and that is that if we look at how we're moving, we're all silky smooth, and moving at a constant rate. But as soon as we go diagonal, we suddenly start moving quicker. And this is because we're moving at a speed of 1 down and a speed of 1. We're moving at a speed of 1 in the X and a speed of 1 in the Y direction as well. So we probably need to fix that a bit. So if we change this around a bit, what we ideally want to do is store the dy is store the change. So we want to go negative speed times the value there, or we want to go the actual speed in the Y direction. And then we want to go for the same in the X direction. And then what we can do is standardize this. So we want to go if the X is not equal to, and dy is not equal to 0, then see, this is why this is the use case for AI, in that is pretty much no. I mean, I think that's almost right. Oh, hi Kongville, welcome in. So far we have we've had a little look at the Love2D engine, and we're having a quick. We have evolved into moving a circle around the screen. So hang on. So what? Do we have a plus equal? No. Okay, so we want to go x plus delta x and y equals y plus delta y. Things are good. We have gotten to a point where we can move a circle around the screen. So we now have a controllable circle. At the moment, though, I'm looking at can I fix the fact that we move quicker on diagonals than we do on the straight? But yeah, so if I remember my maths right, an angle. We want to take we want to pick the point on a triangle between these. Well, we need to normalize these so that they're not things, and so which is, well, I think it's the square root of 2, if I remember right. Times the square root of 2. The AI seems to think that it's resonating with me. Let's give this a quick go. And what do we have now? Oh no, that is definitely wrong. We actually just made the problem worse. Okay, so let's consult the oracle of all things maths. What do we want to know about? We'll normalize the x and y distance, so it's sort of, no, we want, here we go. We want Pythagorean. I think this is what we're actually after. So a squared plus b squared is c squared. That is the, oh, hang on. Will it show us a right? Here we go, right triangle. So what we want is we want to take this distance. When we're moving, we want to pick the point that is midway along this, I think, which if we look at the maths for that is we effectively want to find side C, and that is the Pythagoras, that is the Pythagoras theorem, which is a squared plus b squared equals c squared. Oh. So if we take, so both of these, then we want to go equals these. Okay, yeah. So we want to go, but I want to actually do it with dx and dy. So we want dx squared plus dy squared. That will give us the length. No, maybe, hang on. Well, I'll tell you what. We can live with this for now, I think. And I will actually go read up on the maths on this after. I do, as it's completely gone from my head. So stream of brain and things is kicking in, and we can just. I'll come back. We can fix this. We can have a look at this in the next one. But we do have a object moving around the screen, and that feels like a good. That feels like a good bit of progress, right? We've got something moving on screen that is that's getting close towards the criteria for a game, right? We have user input, we have the screen updating based on that user input. Yeah, it's like It's weird. I work with maths on a daily basis now. I can't remember basic high school maths, but the what oh, if I actually yeah if we have a quick look in at here, a new. Let's create a new. Oh no, that's not what I wanted. That is far too many zeros on one of the axes there. So new. Sorry. I realize it's not actually showing you the when I open a menu, which is not helpful. File, new, yeah, 100 pixels by 100 pixels, create. Okay. But yeah, the thing that I was actually after, where is the pencil in this? Yeah, that'll do. Smaller pencil. Yeah, so, so if we, so if we have a circle and we're here, we have this is our distance in one direction, this is our distance in the other direction. But what we were ending up with was this distance, whereas what we actually wanted was this distance. In a very naive thing. So I need to try and remind myself of what the so this is also going to be yeah, so it wasn't the distance on the triangle as I was thinking. So we need to round it. And calculate the angle. So calculate the distance in the offset in x and y based on that. So effectively we're going to chop off that part and we need to figure out what this, and if we chop off that part, we need to figure out what those two values are, and then we can get this one. But I will maths that out at another point. And where is my eraser? There we go. Cool. So what we can start with next is, I guess we can look at doing some images, getting some graphics into this game. So here we go. So hang on, I think what we're going to need is let's create ourselves a nice little 32-bit sprite. The tooling is not with me today, so it refuses to actually recognize the value I've entered until I exit out. So Let's show you the grid. What do we know? Yeah, we want a pixel grid. Here, and do we have a pencil tool? Because we want something that is a bit more concrete. What have we got? View. It's been a while since I last used the Affinity photo, to be honest. I normally use the that's the one we want. So I normally use the designer for stuff, but we are going to want some pixel perfection on this, and I assume because I could use one, I could use the other, which is going to mean that we have a little bit more of a learning curve here, in that we're going to need to get to grips with the tooling here as well. So yeah, if we create a small little character here, let's go for something basic. So we'll try and draw a small slime creature. Seems like a good thing to be moving around as our first sort of sprite in the game. Here we go. We'll give it a quick shape. We can touch this up a bit later, but then give it a blue color. And then we will probably need to give it a little bit. Sorry, we will then probably need to give it a bit of a highlight. I will warn now that drawing is not my strongest point. This is something else I want to try and improve as we go on with these streams. So I'm going to try and brush up my pixel art in the background a bit. Yeah, it's yeah, the streamer brain is an interesting concept. I never really got it until I started trying to stream for myself. I feel like this is a bit tall, so can we split these into two separate layers, and then if we move this one up a bit, yeah, that looks a bit more like it. That's centered, and if we go there, that's 9 from each side. That'll do. So we will, we will export this guy. And he can go into our code. And we'll put this in our data, and we'll have a create assets folder. And we'll create images inside that, because we'll put probably have some sounds and stuff in the future. And this can be slime.png. All right, so now that we've got that, we can come back here if we have a look. So this should be in under assets, we have our slime picture. And we'll go for love.graphics.new image, and this is in data assets images slime.png. And then if we come back to here, we can go love.draw, and we'll go our slime, we'll go X, Y. Let's actually have a look at the documentation for the draw method. So if we draw, we have a drawable, we have an X and a Y. R is the orientation, so that we will just leave as 0. We have a scale factor, which we don't really mind so much. We have an origin on the X and Y axis. Okay, that. So yeah, if we go with these, we're going to want a scale factor of 1, 0, and 0. So that's our X, our Y, our X, our Y, our rotation, or our orientation or radians. So then we have our scale factor, which we want to set to 1, because we don't want to change we don't want a scale factor of like 2 would make it twice as big, and a scale factor of 0.5 would make it half the size. So we want to try and keep it as the size we drew it. And then we have the origin X and the origin Y. So those will be important in a sec, but we will just, for now, we will get rid of our circle. And then if we run our game, in theory, if everything worked. So we've added the slime image to be loaded here. We've added our draw function for drawing the slime. And if we run the game, which we can do with F5, then okay, that's sort of getting there. But we have our slime, our picture of the slime, and we can move that around. So I think what we want to do is come back to our picture, and we're going to fill this in, and we're going to pick like we're going to pick green. Oh. Cool. We'll move those up up to the layer above that, so that gives it our picture of green background. Let's export that again. So we now have a green background on our slime. And we want to, and now what we want to do is figure out how to make the image background transparent. So this is probably in love.graphics actually. So if we take this and we have new image, so we have an image here, and can we set a transparent color? Is it a new image? Is it in the new image function itself? So we have a file name and a format. Okay. So so I think what we'll do instead is we will get rid of the background completely. Then when we where is the image status in this? So what I've misplaced is the actual settings for the document itself. So because I want to try and export it with the background as transparent. Sorry, document, here we go. So there should be a transparent background. That's what we want. So now if I export this again, oh no, that was not what we wanted. Trigger happy. There we go. Export slime.png, replace it, yes. Now if we come back to our game and we run it with F5, here we go. So we have a slime creature in the world moving around with a transparent background. And that is our first sprite. It's in the game and it's moving around. So the trouble is this here is a bit messy at the moment. So what we probably want to do is have we'll have our slime, but we'll create a new table, and a table is a structure in Lua. It's like an object. So it basically either holds a series of events, a series of other values, or including potentially other tables, or it holds named values. So in this case, we're going to have x is equal to 400. 300, we're going to have the speed at which it's moving, and then we're going to have the image in there. Thanks for dropping in, Kong, and well, I hope the cats enjoy being fed. The taking care of the kitties is definitely important. So yeah, so we can then have this. We can also there we go. We can split this into a position. And then so we can actually arrange this into various aspects of the thing as well. So we can store the position, all of the position stuff together. Oh. There we go. that is the dyslexia hitting live on stage. So we have our slime, and then we can refactor some of this around so that when we draw it, we draw the slime. We can also add a method into this. So when we update, we will and I missed the comma there. So we can move the update logic into this, and we can also have the actually let's make that delta, and then we'll also give it a okay. So we can create a key press function, which thankfully Copilot has actually filled in pretty much as I was going to. So when the W is pressed, we're going to set the delta on the position to the speed. Actually, no. Now I've done this. What I want is an X and Y there. And then what we want is a velocity actually instead. And the velocity will be X and Y as well. And when we do this, we want to increase position.velocity by, position.x with velocity.x. And we want to do the same with Y. And then what we want to do is when the W key is held down, then we want the velocity x to decrease by the speed, and we want the velocity s to increase by the speed when s is held down. Oh, sorry, that was meant. No, I've done that the wrong way around. So that is the velocity y when with W and the velocity y with s. Velocity x decreases when a is held down and increases when d is. And then what is it suggesting? Yep, this. And then when we release those keys, we want to set the value back to 0. And then when we in our update function, this can go away. We can go we can update the slime. And then we can also add on top of this, we have the update there. We can also add a draw. And this will draw the image at the position X and position Y. And then in here we can just go slime, slime.draw. And then if we run the game now, then nothing is happening. So why is that? Why is that? I wonder. So let's have a let's see what's happening when we press a key. So if we hide the game window, I've now set it so that so it doesn't look like our key press. method is working. No, this is the trouble with AI, and when you don't fully understand the problem domain, is it's making crap up again. And what we wanted was key pressed and key released. So the fun with working the fun thing of working with code generation AI is it's like having a very talented junior working with you, but one that sinks a lot of acid. And they most of the time it does good work, but you just have to be careful of when they're actually just like completely tripping balls and they have no idea what they're on about. So with that, if we stop our game and we run it again, then now we have our little character moving around again. And what we've done here is we've created our first game object. I think is the term from when I was having a quick Google on this stuff. So by creating we've given the slime a position and a velocity. We've given it a speed, and this is all information related to the slime. And then the slime has its own method for updating the logic in it each sort of fraction of a second. So we'll get our fraction here, and for every time this method is called, we want to increase its position by the velocity, but rounded to the ratio of how much of a second has passed, how much time has passed since the last time. So we're effectively saying for every second we want to move the character by speed. If half a second has passed, we want to move the character by velocity. So if half a second has passed, we will increase x by half its x velocity and half its y velocity. If 2 seconds have passed, then we'll increase it by double the x velocity and double the y velocity, which means that no matter how fast the game is actually running, the speed at which the character moves should be constant, even if the game is being choppy with the number of frames in which it's rendering. So that has given us our first object. So one thing we could also do is we can have and go. If we really wanted to push this further as well, we could even move the key pressed and the key released data into this object. Missing that final comma again. Sorry. So this has moved the logic that we had down below in here. So this is now operating on it directly, and we can also go like that to reset the velocity. when a key is released, and then in our global one we can go slime.keyPressed with the key and slime.keyReleased with the key, and then if we run that again, if we run that again, then nothing happens. So what did we do wrong? So we have keep. Let's put a breakpoint there. And this is where our debugger from earlier will come in. So that when we press a key, we will see that we're now in here, and we can step through what is actually happening. So if we step into this, okay, key is nil. Oh, because we didn't. Okay, sorry, that is the problem. We didn't add the. So this function, we didn't add the key parameter to it. There we go. Quick fix there. Give it another. We'll give it another run. Hey. And now we have our slime, and it's moving around as we enter the keys. Okay, what we can also do is so if we have this slime and we've got this logic and we go, okay, table dot insert objects and our slime. Then in these functions, we instead of calling the slime directly, we can go for yeah. So for object in objects, if that object has a key press function, then we want to call the key press function of that object with the key. And then we can take out our slime. And then we can do the same for released. The same for update, and the same for the draw. Because this is actually and then that means that we can then have as many objects on our screen as we want, and then they will all show up in the world. So if we now add another slime and we take out the key press and the two key press buttons, we could set another one to be sort of 200, and I don't know, we'll just pick a random location for it. We can give it a little velocity. It doesn't need a speed. And then we can add that into our thing as well. Actually, these are probably better. It's probably better to put these underneath the ones that they go with. So we can have our second slime there. And if we run the we have an error on line 108. what do we have here? 4 if. We're missing the end here. There we go. So let's give that another run. There we go, and we have our slime here, and we have another slime here that is ever so slowly moving, as we can see. He's moving a bit too slow though, so let's go and give him a bit more gusto. So we can set his velocity to something else. Let's give him. Let's say you can move at 50, and then when we hit 5 again, yeah. So we are moving, and we've got the other slime in there that moves as well. Oh, sorry. And yeah, so what we have here is the start of a game engine. So what you will see in something like Godot or Unity or whatever is that this sort of thing will be entirely sort of abstracted away from you, and it will be doing much the same as this under the hood. So in Godot or Unity, you will basically create objects, or I think is it nodes in Godot. These all have like behavior attached to them. And we've basically for each of the different types of thing of behavior that is available on each frame, we will go through each of the objects and we will call the relevant methods if they exist, and they will update their internal state. So yeah, it's oh, sorry. It's not the prettiest of setups at the moment, but let's try and zoom out a little bit. Hopefully that's all still visible. It's not gone too small. But yeah, so we have. I can probably compress some of these functions. That will make it easier to see what we've got. There we go. Yeah, so these game objects or entities or whatever you want to call them, they each have their logic attached to them. I think there's some patterns around extracting that, and we might have a look at some of that in the future, but I think this is close for now. So what we'll probably do to begin with is take something along this lines and tidy it up more, because there's a lot of reused code around here, right? So this position code and this update code is all, and the draw code is pretty standard. So what we probably want to do is make the logic a bit more composable. So we can actually define some of this as function like this, and then when we come in here, we can go we want a draw method, and we want an up on there, and we want our draw method on this one. We also want to have and that we can then drop into into those. So that's now given us, so now rather than have that logic duplicated in each of them, that it's now just here centrally in our little sprite draw and sprite move method, and we can just give that to anything now that has the relevant properties. So as long as it has a position and a velocity, it will update we will update the sprite. And as long as it has an image and a position, we can draw it. Although we could actually go, so I know we abstracted some of this away, but we could kind of go the other way, right? And we could say that, no, I think this will do for now. So yeah, so in other languages, what you tend to do is these would be sort of classes. We don't really have classes in Lua. We have because we don't really have classes and objects and a whole hierarchy of inheritance like you would in something like C# in a Unity project, or I think it's GDScript has like in Godot, or C++ has in Unreal things. Because we don't really have those, we don't really have inheritance as such. But if I remember correctly, what we do have is metatables. Actually no, we're probably getting that's I feel right. That's probably a bit too much to look at right now. I don't want to start reinventing object-oriented programming in the first stream, because it's going to end badly for me. It's gonna be boring for you. But yeah, so we've effectively now built a very basic game engine from scratch. As I said, we only have. I started that and then it's all gone a bit bizarre. So let's have a look and see if we can figure out where things went wrong there. So we have sprite, and we're drawing it at X and Y. We have the X and Y of the here as well, that we're increasing based on the velocity. The velocity is set to 0. Sorry, the move needs the dt. So what happened is when I started the game, the sprite instantly shot off in the direction that it was going in, because every single frame it was moving 100 pixels, and we don't actually have that many on our screen at the moment. So yeah, if we run that again, we can see that we now have our logic. I have just noticed that we have there is a small problem that if we change X and Y, so the way I did the movement, if I hold down one key and press the opposite direction and then release it, we stay still and we don't start moving back in the other direction. So that is probably based on how I did the movement here. So I guess instead of the, instead of that, we will want to, in our update method, we'll go function self dt, and then we will go end. So we've now got this function here. We can then call the sprite move at the end of this. And what we want to do is go if love dot and same for s. Yeah. Well, what I find the the AI assistant is very good at is that if I do one thing and I need to do it over and over again, it's quite good at picking that up and then just rolling with it. There we go, WASD. So we decrease on W and A and we increase on S and D. And then in our standard function, which moves the sprite, we can call that from inside this, which will mean that we'll get all that same behavior, and we can do the same here. And now if we run it again, we will find that we have the movement is more smooth, so we can actually that is we have a small problem there, is that when we press a key it keeps going now, so we want to reset velocity at the start. Oh, there we go. And now, so now if we hold two keys down, it will, in opposite directions, it will default. One will always have preference over the other at the moment, but it will pick up that the other one is pressed down when we lift it, the other one up. So yeah, we have movement. But just although we can improve this a bit more, I think, by if we take the velocity and modify it by speed. And then self dot velocity x equals, oh, sorry. Yeah, so if we then take the min of velocity x and speed, and the max of that value and minus speed, we will constrain the values, and the same for the y. So what we're doing here is, instead of adding speed, sorry, instead of setting it to the speed, we're going to add or subtract the speed from it, which means if both keys are held down, if you hold down both keys for both directions at the same time, they will cancel each other out and they'll meet in the middle. Oh, sorry, I have the game window open again. Yeah, so by adding a speed, so instead we're sort of going, if we say we're going this way and then we sort of head the other way, press the key to go the other way, those two things will cancel each other out and we'll end up in the middle rather than one trumping the other. And that should give us a bit more of a sensible sort of movement. So if we're holding down W, we will be moving at a negative speed. If we're holding down in the vertical direction, if we're holding down S, we'll be moving in a positive direction on the W direction and the vertical direction. But if we're holding down W and S, we will subtract the speed from the rate at which we're moving and add it back as well, which will take us back to nothing. And then we constrain it to actually no, this is completely unnecessary because we're resetting the speed here. Sorry, we're setting the velocity there. So yeah, so if we run that now, then if we hold down D, we go to the right, A, we go to the left, and if we hold down both of those at the same time, we stay exactly where we are until the key is released, and the same for W and for S. So we've got some sensible-ish movement there. And that feels pretty smooth to move around with. Cool. Okay, so we've got our we have our basic thing moving around now. And but we're just moving around in a black void. So if we come back to our images, if we create another image now, what I want to do is just we'll draw some decent we'll draw some decent tiles for it very soon, but we'll go for now we're just going to go a bit retro. And we can maybe have a stream where we start looking at some of the graphics, getting a tile set together. But if we export that and we call it tiles, we only have one tile for now, but we will aim for the future. Here we go. So that is now. We can get rid of this one that I missaved earlier. We have a tile, and we have our little sprite, and we can have a quick look at a basic map. So we okay. So yeah, if we have a yeah, so we want our map to be a this is overcomplicated a bit. There we go. So we're going to have a map, and we're going to have a bunch of tiles in here. I was actually going to go the other way around. It's probably... It was solving the stream of rain problem of, oh, how big should I actually make this? But so let's put in a couple of... Actually, let's go a bit bigger on that direction. So this is effectively giving us a grid. So we can sort of draw in here where we want our tiles on the map. And we're just going to try and draw a rough little circle for now. Well, we'll draw a little splodgy shape. So it's going to sort of curve around like that. And these will be our graphs. Yeah, so we can do animations as well. We're going to have to get to that in a bit. But what we can do is we can change the image that we're showing, and if we say each frame of the animation lasts a certain amount of time, we can use the DT method. So where we're moving here, what we could also do is advance a timer, and every time that timer goes over a certain amount, we decrease it by the length of the frame, animation frame, and we update to the next image in the series. And I think that might actually be the next thing that we look at after we try and get a little bit of a basic background drawn. So okay, no, so that's drawing a rectangle. We want to load an image here, so we're going to go we're going to want to load tiles, which is our image there. And then if we go back to the wiki again, and we want to look at the graphics, and what we want to do is draw a section of an image. So can we get... So we want to get a region of it. So it doesn't look like there's a method on the graphic itself. So is it in? Is it draw quad? Is it, okay. No, this is merged into here. Okay. So when we look at this, we have an origin. We have the origin and the shearing factor. What is? Hang on. No, so we have some different options here. We also have a transformation object. That might be what we're after. Here we go. Let's draw the top half of an image. Okay, so we want a quad for each tile. So we will want in here, we'll have a list. So the first one will go with nil, which is nothing. And then we'll have a quad of 0, 0. Sorry. Oh, hang on. I'm still on. Sorry, I'm still on the browser. Right. So we've got that. So what we want the quad. So that is also in love.graphics, I think. Yeah. So quad. So we want a new quad. Object creation. New quad. Here we go. In which we have the top position of XY, the width and height, and reference width and height. Okay, so given that, if we come back to our code, so we're going to want some tiles, and we'll set the first one of that to nil, which is a value in Lua that just means nothing. And then when we load the thing, we will load our tile set, and then we'll go for I equals 1 to the tile set. Sorry, I'm just quickly having a quick look at the image again. So we want to get the width, which is get dimensions. Okay, so we want width height equals tileset dot get dimensions, and then we want to go for this to the floor of width divided by 32, and we want to have new quad, and that quad is going to be the square around the tile itself. So this will set us up so that we can just add tiles into that array. Sorry, into that image, and every 32 pixels will be a new tile. So with this we want to go from the first value is our x, which is 1 minus 1, which will give us 0, times 32. So that will give us a series that is 0, 32, 64, 96, 128, and so on. So it will move across in increments of 30, and we want the y to be 0. We have a width of 30, a height of 30, and then this is going to be our tile set, which we then pass in as the final parameter. And then down here, when we are drawing, we will go, we want to draw the tile set. Oh no, that's our, sorry, that's our, that was our objects we were drawing there, not the map. So here, yeah, we want to go x is 30, y is 30. We want to draw the tile set, and we want to draw that in we want to draw a region of that is the tile, like so, and tile is greater than 0, then we draw at that position. Hang on. Width, height, and we want 32 and 32. Sorry, and I forget that in most languages a array starts at number 0, whereas in Lua it's actually a bit more sensible and starts at 1. At some point years ago, all languages, an array started at number 1, and then C and C++ came along and they decided that they were going to be different and start at 0. And then everyone else copied that and the madness proliferated. But Lua looked at things and were like, why are we doing this? And they took the sensible road. Just means that it's ever so slightly different. Okay. So we've got a error here. This is, okay, a line 93. So what did I do here? It's probably something British. Sorry, it was tiles. That's the one. So we run this again. Oh, that is not what I was expecting. We have a weird rendering. So okay, so with that in mind, let us retreat to the wiki again, and we want to look at the draw function. And I must have missed something here. So okay, so we need to draw with a transform. Actually, no. Hang on. If we take all these out, this might be what we need. Yeah, we just need to give it a location. Yeah. Okay. So this has come out a bit small, but we've sort of got the start of a map here, right? So this matches the map that we sort of sketched out briefly. Oh, yeah. Sorry. So what I realized is I had those in the way and those were not right. So if we run, I actually show the game window. What we have here is a set of the tiles. These are the tiles that I sort of sketched out in that array at the top. So they match up with here. They're ever so slightly over, which is not what we're after. And I believe that is because what we actually want to do is x minus 1 here and y minus 1 here, because we are counting through, we're going through, and y is equal to the hello Dom, and thank you for the compliment or sarcasm, knowing you. Yeah, so we've got, but as I was going back to this, we are looping through each thing and we're recording the y and the x, but because it starts at 1 rather than 0, when we did x times the width, it gave us it put us a bit further over than we were hoping. So so yeah, so if we run it again now, we find that the tiles are where they should be. And then I think we just need to expand this. We need to just need to expand this to fill the whole screen now. So we can add a bit more width to it. We'll put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. 10 extra tiles across. And we'll just sort of expand this out a little bit so it's wider. And this is like, this is the basics of any map. Any map in any game, that two-dimensional game. Let me know if I want some poorly drawn pictures. I mean, I've seen your art style, and I will try. I will consider coming back to you on this. All right, so we'll mix up the bottom. And we'll put a mix of we'll put a bit of jaggedness along the bottom, so it looks a bit more random. Okay. Oh, sorry. So if we have that now and we run the game again, then we have a syntax error on line 24. Ah, we missed a comma there. That's what we did. There we go. So let's give it another run. And okay, that's a bit better. We've got some space here, sort of thing, and we can sort of move around in it. If we now go back to our badly drawn tile set, you can draw. Splash can draw all kinds of things like lines and blobs. She mentioned the lines. Yeah. I feel like art is definitely the part of this project that I am going to struggle on the most. But I'm sure we'll get to a point where we can. I'm sure we'll get there. We'll get to a point where we can do a bit. Where we improve over time. I hope. So let's expand this out to 64 pixels. No, that's not what I wanted to do. Resize canvas, that's the one, sorry. So we want to go, we want to make this 64 pixels wide. No, sorry, other way around. 64 pixels wide and 32 tall. Resize. So now what we want is like a dirty brown sort of colour. That'll do. Oh. And then if we grab our pixel tool again and we want a sort of a little grey-ish colour. Maybe we start with this one and we make it a bit darker or something. What do we want? HSL. That'll give us Here we go. This can be our sort of dirt texture. Though I think I've got these the wrong way around. I think we probably want them to be the other way around in terms of colors. Let me grab that value. Tolerance down to 0. We don't want to overlap. Let's pick that. We'll take that color. We'll fill in these ones. We'll take the darker color. There we go. It's a bit of a darker color. Yeah. Yeah, I would 100% wager that the very original Minecraft dirt block looked similar to this. Do I have a green screen now? I do not have a green screen. It's one of those. It's just a setting in one of the filters in OBS that I installed in OBS that is taking out the background, but it's a bit weird. My arms and things will fade in and out, and if I lean back a bit too far, then no, I know. If I lean in too far, that's it. I start to disappear. No, okay, it's doing a bit better than it was earlier when I was testing. But yeah, if I there you go. Look, I turn around and half my face disappears. It's not the best, but it's doing the job. Yeah, it's doing the job, and it's not doing too bad a job. It does cut a few bits out, and it likes to make parts of my headphones disappear, for instance. But yeah, so it's fading. It's not good. If the series continues and people actually enjoy it, then maybe at some point I can justify a green screen to myself, which would, we'll see. If we're still going this time next year, then maybe I can buy myself a green screen for Christmas. Yeah, okay. So we've now, given that, we've now got our two textures. We've got our crappy grass and our crappy dirt texture. So what we can start to do is start to put in like tile number 2 around the outside here. Lua is a programming language. It is it was created, I think, in Portugal, or no, well, it's Brazil. I think it's Brazilian for, it's Portuguese for moon, and I think it was even, I think actually it might have been, I think it's Brazilian in origin. But it's it's a very small embeddable language, and it's very fast, very efficient. It's used in a lot of game engines, so everything from some of the older, from some of the sort of not quite so old LucasArts games. I think Grim Fandango and Monkey Island 3 or Monkey Island 3 were written in Lua. World of Warcraft uses a lot of Lua. And so it's a fairly commonly used in the gaming industry, just because it is so small and fast. And when you are I guess when you're calling stuff over and over again every frame, then small and fast is what you want rather than featureful. So yeah, if we go around here in our tile set, so we're now mixing in some of our tile 2 into the mix. We will, and I'm thinking we go around, we just try and put these around the edge of the grass ones for now. Yeah, so I'm thinking the game that we're building will be top down. At the moment, these are just sort of temporary things. But yeah, so now we have a tile engine that can show multiple tiles, and we have a sprite that can move around on top of it. And I think we're probably at a good spot to call things for today. All of this, as I said we will have to draw a proper character sprite at some point, and we'll have to do some work around collision, because at the moment I can just sort of walk off the edge. But we have the guts here of a game, right? We've got our tile map, and we've got our sprites. Maybe next week we can have a look at adding a little bit of animation to the sprites, and yeah. So, oh, sorry, I'm running the game again and not showing that window. I have a whole thing of windows in front of me at the moment. So what we have is we have a bunch of game objects, including the slime that sort of runs off the bottom of the screen there. We've got movement based on keyboard input. So this little guy is moving around based on the keys that I press, and like hitting the WASD keys. We have a basic tile map with 2 tiles. And then our effectively, if we include the 0 tile, which is the no tile, then we have 3 tiles. But so we can draw a basic map. We have the most basic slime sprite ever made, and the ugliest tile set in the history of creation. But yeah, all in all, I think that's not too bad for our progress for the day. So if I get rid of the game window, so our map is basically just an array of a 2-dimensional array. So we have of the tile IDs. Our tiles are a bunch of quads in the image. So we've created a new quad for every 32 pixels across on that image, and added those into our into our tile set. The tile set is one image. We have these game objects, which at the moment are the slimes, and they each have a position, velocity, speed. This one has some input controls, and they update continuously. So we have functions for updating them and functions for drawing them, which are reused. And we can give that to any other object. And yeah, this as I said, this method is called periodically to update the game state, and is given a time. So we use this to update the entire game state periodically. And then we have our draw function, which at the moment loops over the map and draws out the tiles for that. And we have our and then it loops over all of our objects and draws those onto the screen as well. So yeah, so it's fairly basic, but it's a start. It's a start, and it's something we can start to build on, right? So as we move on, we'll look at improving these game objects. So we want to get like a little system together to help us create those, and to maybe to mix in the different behaviors as well. So we can have like a movable one and a movable and a sort of a drawable sort of behavior, and then we can mix those into the objects. we'll want to tidy up the map code, because at the moment we have a single layer map. We'll probably want at least three layers of tiles, maybe two layers of tiles. We at least want 2 layers. We want one that sits above the objects and one that sits below, because and then so we want to draw one layer above, then we have our objects, and when we have a layer of tiles below, and that way we can sort of have walls and things that we can walk behind. And then we want to get some animation into the mix as well, so that like our little sprites can just move around a little bit and have a little bit of an animation. And then we're going to need better graphics and assets and stuff. And once we've got that in place, then we can start looking at procedurally generating some maps, which will be the core of our game. Because what we're looking to do is to generate these maps programmatically, and that is for two reasons. One, because I'm too lazy to make a whole bunch of dungeon levels, and two, because we can use and two is because that way we get a lot more reusability in the game, right? It's more replayable. So every time the idea is going to be that we're going to have the game will be that we'll have some sort of overworld, and then the characters from the character will sort of venture into our dungeon to explore, and each time they enter because of magic. We'll write some better lore around that at some point. The dungeon will regenerate, or maybe the dungeon will just generate once when you start the game, and that's the dungeon you get. We can have a think about that as we go on, but yeah, we want to make sure that every time that effectively each playthrough of the game you're going to get something new and something different, which is where the procedural generation comes in. And the upside of that, as I said, is that I can write algorithms instead of doing level design. But trying to come up with an algorithm that will generate us a good, fun level to play, that is where it's going to get interesting. So I feel like it doesn't look like much now, but I feel like technically under the hood we've got a bit of progress made today, and thank you for joining, and hopefully I will see you guys again next week for another installment. Bye. Oh, sorry, and forgetting to be a proper YouTuber, remember to like the video, subscribe, and hit the notification bell. And God, I hate doing that bit, but anyway, thank you for joining, and I will see you all next week.